Welcome to Study Loop.
Problem 7.1. So here we have a mountain climber climbing up and down a cliff. On the first day, she starts at an elevation of 1,500 meters and then climbs to the top of the cliff at 2,400 meters. And on the second day, she climbs from the top of the cliff down to the bottom, which we're told is at an elevation of 1,350 meters. So what we'd like to find is her change in gravitational potential energy for the first day and the second day. So we know that the gravitational potential energy is equal to the mass of the object times the acceleration due to gravity times the height, or the y-coordinate, or whatever you like. And so the change in potential energy is equal to the difference of these two things at two different times or places, and the mass of the object doesn't change, and the acceleration of gravity doesn't change, at least in this problem. And so then only the change in height matters. So using this, the change in height is going to be 2,400 meters minus 1,500 meters. Which is, like 900 meters? Yeah. So delta U, we know, is mg delta h. And so this is going to be positive because this is greater than this. 6.6 times 10 to the 5th joules. Now on the second day, our delta H is going to be the final elevation, which is 1,350 meters, at minus the initial, which is 2,400. 2,400 meters, and so our delta H is negative because the initial is higher now. And this is 1,050 meters. And so then plugging in this for delta H and M and G the same as always, or G the same as always, and M is 75 kilograms. In descending, her change in potential energy is negative, which we would expect because she's going lower. This is 7.7 times 10 to the 5th joules, which is bigger, which we would hope to be the case because the distance in height between these 2 points is less than the distance in height between these two, although this is not drawn to scale very well, actually. But in any event, so this is bigger like we would expect, and is also negative. So this all works out.